We're starting with lesson 3-6. And some of you, as we go through this lesson, are going to start realizing, wait, haven't we already done this before? And in a sense, we have. But we're talking about solving inequalities, and that's the key word, inequalities, using or by adding or subtracting. Adding or subtracting. So this is the key to the lesson. We're talking about inequalities, and we're talking about adding or subtracting. Super important. Okay, so I asked the question, what are, and you've dealt with these already, but I hope you know what they are. What are inequalities? So can anyone answer me that? What's an inequality? I know adding and subtracting, I hope. What's an inequality? That's a tough one, guys. You want to try, Parker?
Any whole number. Or like negative and positive.
Oh, so I think you're thinking of like integers.
Oh, yeah, never mind.
Yeah, so that's kind of close. What's an inequality?
Aren't they like the things of like the less than and the greater?
Okay, when you think of inequalities, you should think of these symbols. The less than symbol, or the greater than symbol, and there's technically another one, the not equal to symbol, okay? So, equations, this is review, equations always have what symbol? Equal sign. Inequalities have either less than, greater than, or the not equal to. So something does not equal another. I need a volunteer here to help illustrate this. Betsy, come on up. And stand right here, please. Right here. Last class, this made me cry after a while, but yeah, you'll find out. Okay, so Betsy, thank you. All right, do you guys remember with equations how we had a balanced scale? Okay, today, it's not balanced. Okay, now, honestly, can you guys go with your hands and show me how the scales would look here? No, show me. So wouldn't it be, remember, who's the heavier side? Good, thank you guys. Thank you, Betsy, for making me feel bad. But anyway, keep going there. Keep it like that. I know, it's like you're doing like an Egyptian dance. Don't do it. Yeah, don't do it. Anyway, you're like this, right? Okay, I would say that Mr. A, in terms of size, okay, is greater than Betsy, right? Would you guys agree with that? Or Betsy, can we switch spots? Just go over here, I'll go over here. Or we can say Betsy is less than Mr. A. Do you guys understand that? Let's switch again. Okay, so show me the scale. There you go, yes. Yeah, so it should be like this, right? It's heavier on this side, so it's like, it's leaning on that side. Good. Okay, I need a couple volunteers. Sarah H., bring me your book. And Peter, bring your book to Betsy, please. Okay, ready? Now, you just added some weight to Mr. A. But what did you do to Betsy? You added the same weight. And yeah, we're assuming they're both the same pre-algebra books. So guys, show me the scales again. What should it look like? It should look the same way, right? Like it was like this, so you added the same thing to both of us. There you go. Ready? Sarah, come get your book back. Show me the scales, how they changed. Hold on, sorry. Just stay right there, Sarah. Okay, show me what it's like right now. Show me what it's like right now. Everyone, come on. Not everyone's doing it. Okay, watch when Sarah takes the book away. I want to see how you guys react with the scale. Go ahead, Sarah. So how does it react? Okay, I see some of it, but it should do this. Look, you were like this, and when she took the book from this side, it should have gone like that. Not like this, right? But it should have just gone a little bit over to her side now. Peter, come get your book. You're doing a great job holding that book, Betsy. Great job. So take that book. Now watch what happens. It goes back to the original, doesn't it? Okay. Thank you, Betsy. You can take a seat. You were a great weight. Great weight, yes. If I would have asked any weight to do something, I would have asked them that. Thank you. All right, anyway. On my scale, you notice that it was like this. When I took away the same thing from both sides, did anything change? When I took it from both sides, did anything change? Nope. When I added something to both sides, did anything change? No. What does that sound a lot like? equalities. It's the same exact concept, except now we're dealing with inequalities. One side is bigger than the other. So you're like, okay, what are you talking about? Look on page 147, and let's look at the very top where it says addition and subtraction properties of inequalities. Okay, more properties. Okay, which looks a lot like properties of equality. Can someone read that in words part where it says in words? Okay, Chelsea.
Adding or subtracting the same number from each side of an equality does not change the truth of the inequality.
Does that make sense? If you take away the same thing from both sides, you took away the book, you took away the book. Do I change that inequality? Nope. If I add the book and add the book here, do I change the inequality? No. So let's see if you guys can remember that. Can someone read for me in symbols? Okay. Sarah, Curtis here, read for all numbers.
For all numbers a, b, and c, if a is greater than b, then a plus c is greater than b plus c, and a minus c is greater than b minus c.
Okay, pause. Get over that. Oh my goodness. What did she just read? Okay, this is all it was. Ready? Ready? Oh, Betsy, this worked out perfectly. Ready? I'm A. Betsy is B. It almost worked in the other class. I didn't plan it, but okay. A was greater than B. Do you guys agree with that? When I added C to both of us, wasn't it still A is greater than B? When I took away C from both sides, wasn't it still A is greater than B? So did I change the truthfulness of the inequality? No. Okay. Read the second one, please.
If a is less than b, then a plus c is less than b plus c, and a minus c is less than b minus c.
Okay, I hope you read that right, because I totally got lost after a while. Okay, if we did this, Mr. A comes to this side, and Betsy goes on that side, you got to think about it. Betsy is now A. Is that okay? Can you do that? Can you flip your mind around? And Mr. A is B. So it would be A is less than B. So how would that scale look? Right? If you take away something from both of us, or give us both something, doesn't it still stay like this? So that's all it's saying with those symbols, okay? So it's not too complicated. All right. What are inequalities? Statements that have these symbols here. Okay. Let's look at a problem, see how we actually work it out. Look at example number 1. So go ahead and write example number 1. Solve m plus 4. M plus 4 is less than 9. Okay. And the way, and I told the other class, I didn't plan it out this way, honestly, I can't take credit. But the way that fall break came in the middle of this chapter worked out perfectly. Because today we're talking about inequalities with adding and subtracting. Tomorrow it's going to be multiplying and dividing, and it's split up this chapter right down the middle. We're reviewing. Just like with the equations, we're trying to solve for m. Do you remember how to solve for m? Here's your first step. Find m. Found it. First step done. Got it? You found it? What's happening to m right now? It's being added with 4. That was your second step. Identify what's happening to that variable. Added with 4. What undoes addition of 4? Subtraction of 4. And you do it from both sides. So I'm going to show that. I'm going to subtract 4 from both sides. You remember this? Like, wow, that seems like a long time ago. Yes, it was about a week ago.
Instead of the equal sign.
It's just your inequality, whatever it is, less than or greater than. Yep. Okay, so what's 4 minus 4? 0, right? So they got eliminated. And what are you left with on the left? M is still less than, what's 9 minus 4? 5. This is your inequality.
So it's not like negative becomes, or is it going to be, or?
We're going to have it, this one, thankfully, is a positive. Very nice. But I have a deep question for you. Listen up here. Ready?
Oh no.
Deep question. So don't answer right away. How many answers are in this solution? So don't answer. Think about it. How many answers are in this solution? Okay, now I'm going to ask, how many answers is this solution? Josh? What? How'd you get infinite? Yeah, good. What through your intelligence helped you to understand that?
And then
numbers going forever, they go forever backwards into the integers.
Okay, does this say that m is equal to 5? No, because if it said that, there's one answer, right? 5. But this says m is less than 5. So give me some numbers that are less than 5. Raise your hand, give me a number. Yes. 1. Is 1 less than 5? Good. Peter? 0 is less than 5. Good. That's another answer. Yep. 4 is less than 5. Good. Yep.
Negative 14.
Negative 14 is good.
Negative 300.
Negative 300. All right. Your task is to give me all of them right now. Give them all.
M. G.
Okay. Wow. Anyway. Little did you know that the joke's on you. I love that song. I sing it to Ezra all the time. I love it. So thank you for now. Anyway, thank you for those the alphabet. I'm glad you know it. Here's where I'm going to tie in here's where I'm going to tie in your answers to what you've done in the past. Remember with the equation you used to put if you had m equals 5. Remember how you draw a little number line? You write 5 in the middle, and then a closed circle on 5. You remember that, doing a number before and after? Okay. We're going to start off doing the same thing. 5, 6, and then 4. So just number before and after. Yes. I'm going to give you, Chelsea, how about this? I'll give you two options. You can do this or the alternative. I'll tell you that in just a moment. So you do have, I'll give you a choice. Okay. In this case, I start off my number line just like I did with the equations, where I put the number in the middle, a number bigger and smaller, so no problem there. But this time I'm going to draw not a closed circle on 5, but an open circle on 5. And I'll explain why, but I need you to write this right here in your notes. The less than symbol and the greater than symbol, you put an open circle. Okay, just write that down. It's going to be for your benefit, not for me, because now that I've done these many times, okay, now I know what to do. But if you need it, write it. And then the greater than or equal to sign and the less than or equal to sign gets a closed circle. Yes, ma'am?
Shouldn't you put little arrows at the end of the little line?
I'll show you why you probably don't want to do that for now. So I'll show you why. Because, yes, the number line keeps going, but your answer needs to be clearer than that. Okay. So write that down. This is for your reference, because you're going to be, wait, Mr. A, is it open or closed? Well, look at it. Okay, but you see how it says less than? Isn't that up here? So that's an open circle. And I'll explain why. There's a reason behind it. It's not just, we decided it's open, and then this one's closed. Okay, and then to show all the numbers that are part of the solution, which we said are infinite, right? And you gave me some of them, but there are many more. I'm going to draw an arrow to the left with a darkened line on the number line. And I'll tell you what that means. Go ahead and do that. On the line. Don't do it above. Don't do this, guys. Some of you are doing this. Don't do that. That is not how you do it. Because you're going to see later on it's going to be unclear. What am I doing now? You do it on the line. On it. And that'll help you later. So let me explain this right here real quick, because I've just showed you how to write the answer. All right, ready? Okay. There's an open circle on 5 with a line going to the left. You guys see that? Open circle, line going to the left. That represents all the numbers that are part of the solution. Okay? Okay, let's see if that's really true. I don't believe it. Do you see on that example, it says solve and then do what? Check it. If you don't check it, you're going to miss some of these for something so easy. All right, ready? Is 4 darkened?
Yes.
Yeah. It's right here, right? It's darkened right here, and I'll make it clear if you're like, how do you know it's darkened? You see the difference between the two? Okay, 4 is darkened. Is 4 a part of this solution? Let's see. What's 4 plus 4? Is 8 less than 9?
Yeah.
Doesn't 4 fit in there then? Let's get a negative number. Yes?
Negative 30.
Negative 30. What's negative 30 plus 4? Negative 26. Is negative 26 less than 9? Mm-hmm. In fact, how many numbers over here will count as a solution? Infinite numbers. So Chelsea, to your answer, to your question, you can either draw me this or write down all the numbers. So your choice. Yeah.
Can we just write a letter?
No, you have to draw.
Negative A.
No, because there are positive numbers there too. Okay, but anyway. All right. Listen carefully. You see how I have an open circle on 5? You know what that's telling me? 5 is not itself a part of the solution. Well, let's see. 5 plus 4 is what? 9. Is 9 less than 9? No. Let's see. Should 6 fit in the inequality? No, not according to this graph. 6 plus 4? 10. Is 10 less than 9? That's why it's not darkened. In fact, none of those numbers are darkened because none of them will work. Only all the numbers less than 5. Do you see that? I'm showing infinity right there in a graph. This is your answer. That's your answer right there.
So that's not our answer?
No, this is your, And this could be, but they wanted to do it in a number line so you can show me the number. So that's it. Yeah, that's your answer.
That's our homework? Basically, all you gotta do is subtract that number from there, and then y'all remember that?
Yes. But it does get a little more complicated. I'm sorry. Okay, let's look at example number. Oh, actually, you know what? Let's do a practice problem to make sure you guys get it. Page, I'm going to say it once. So everyone's like, listening ears. Zip. Page 148. Oh, no, I'm just giving you a practice problem. Do you see number 1 on underneath checking your understanding? Yeah. Just don't describe how you would explain to a friend, but work out m minus 6 is less than 3. M minus 6 is less than 3. That's the problem. So just do it like this. I'll even write it for you. M minus 6 is less than 3. So solve that. So you're looking at it, you're like, okay, where's the variable? Right here. What's happening to the variable is being subtracted with 6. What undoes subtraction of 6? Adding 6. So I add 6 to both sides. These will cancel out because negative 6 plus 6 is 0. So that's nice. They got rid of them. And then m is less than 9. That is not my solution. That's a statement for it, but that's not the final answer. My final answer is a number line. So I'll start my 9, my 10, and my 8. So these number lines I did for the equations, they were just practice for these problems. Here, I'm going to give you some hope. Remember the equations where you had to draw a number line and a dot? Yes. You don't have to do that ever again. But for these, you do have to make a number line because there's no other way to do it.
Wait, so you don't have to do the dot
in the equations when you have the equal sign. But inequalities, you have to do this. Yeah.
Wait,
So we don't have to
For equations.
these are inequalities.
These are inequalities. Emily? Okay, do you get this right here? Right here? Did you put this down?
Yeah, but I have a different error.
Okay, I haven't done an error yet, so.
Yeah, when I did it out, when did it close?
Okay, how many of you would agree that it's an open circle? Why is it an open circle here? Here you go, Emily. If it's less than or greater than, you put an open circle. If it had the greater than or equal to or less than or equal to, it's a closed one. Basically, it's this, guys. On the open circles, so on the open circles here, is 9 a solution? No, it's anything maybe before or after, but let's see. Let's answer that question. Where should the arrow go? How would you say m is less than 9? You would say the arrow goes to the? Oh, not above. Which one?
Left.
Left. Yes. I'm trying to emphasize that.
If the arrow thingy is pointing, like if it's pointing that way, the arrow is that way. If it's pointing that way.
Oh, man, what a shortcut. Okay, listen carefully, though, Josh, because I want to help you and anyone else. There's a pattern. if the variable in your inequality that you solve is on the left, it has to be on the left, please. Must be on the left. Has to be on the left. You see where that arrow is pointing to? Where's it pointing to?
To the left.
So where does that arrow go on your graph? That's nice.
So is it pretty much always going to, the dark
It-
one's going to be going?
It's going to follow this inequality symbol if the variable is here. I'm going to go through an example where it's not and show you what to do then. But this, yeah, that's how it works. All right, let's check it real quick. Betsy, give me a number that should be a solution.
What?
7. 7's right here. It's part of it. 7 minus 6 is what? 1. Is 1 less than 3? Check. It works. What should not be a part of the solution? 10 minus 6? 4 is less than 3? No way. No way. So if you drew your number line and you're like, yep, it's this way, and you check, oh, wait, no, that can't be it. So maybe you reverse your thought to switch the arrow the opposite way. That can help you to check it. That's your answer.
So
Me too. Go ahead. Okay. If you get it, ask me again. But let's go to example number 2. Let's finish this up. Last example here.
Oh yeah, so your answer is always going to be
A number line. Yep. Number line. Yes. So the way I'm going to grade the number line is I'm going to say open circle on 5, line going to the right, or closed circle on 5, line going to the right, to the left for you guys. Sorry. I'm trying to do this backwards. Okay, can someone read for me example number 2? Murphy?
Solve negative 13 greater than or equal to x minus 8 and check the solution graph and graph the solution.
Okay, so here's my inequality. How do I know it's an inequality? It has a greater than sign, so it's inequality. That's how you know it's inequality. It's not an equation anymore. It's inequality. All right, my first step is to find the variable. It's right there. Boom, got it. Yes, step 1 complete. What's happening to this variable? Subtracted by 8, which means what do you do to undo that? What do you do to undo that? Add 8 to both sides of the inequality. Always do it to both. If you don't, you're making an imbalanced effort here, and it can't come out right algebraically. Okay, what's negative 8 plus 8? Sorry, negative 8 plus 8. All right, so I'm left here with my x, and I still have my symbol. What's negative 13 plus 8?
negative 5.
Okay, here's what's super tempting to do. What kind of circle should it be? Good, because it has the equal to sign. And it's super tempting to do this. Got it. That's wrong. Stay with me. Don't give up. Someone tell me why it's not right. Where's the variable?
Oh, the variable?
Or tell me
I
what's.
was just going to say because it could be that way or equal.
Okay, so you're thinking of that equal to? Good. I'm glad.
You make it go upward.
Okay, where's that variable?
Both on the right.
So can you use this to tell you which direction it should go?
You can see which way it's opening.
Yeah, and I would say this to help people out. This is what you do. Look at my last two. Please look, guys. I'm trying to help you out because this will throw you off. Where's the variable in this inequality? It's on the left. Where is it here? Left. Where is it? Here.
Right.
So something's different. You don't just follow that arrowhead. That variable, in order to follow this direction, has to be on the left side. Has to be on the left side. Has to be on the left side. Must be on the left side. Okay, ready?
Is the variable always
Yeah, and it doesn't have to be, but in order to use this as the guide, that's what's going to happen. All right, ready, guys? Oh, here we go. Ready? Let's think of it. Which one of these values is greater, x or negative 5? Look at the inequality. Which one's greater?
X.
I heard it. Negative 5, right? Because the arrowhead points to the smaller number. Watch this. Ready? Watch the pen. Is that the same thing?
Yes.
Whoa, I switched everything around.
So now
Which one's the bigger value here?
-5.
-5. Which one's the bigger value here? Same thing, right? I didn't change the inequality. I changed the way it's stated. But where should that, if I'm drawing my real number line, I got my -5, I got my -4, and I got my -6. So I draw my closed circle, arrow to the left. That's clear.
So it's usually always going to go to the left.
No.
No.
This is what our example is. It can go to the right. If it were x is greater than -5. Because it'd be bigger than -5. Okay, listen to me. Ready? I'm going to help you out here. You're like, Mr. A, I totally didn't hear what you said. I'm totally not sure what's going on. I missed it. Okay, so this is what I do. Ready? Let me help you. You said this is your line. I'll say fine. Is -4 part of your solution according to this graph? It is, right? -4 was shaded. So I go back to the original equation. -4, right? -4 is part of the solution. What's -4 minus 8? -4 minus 8. -12. Oh my. Okay, let me just say that just so we're not like confused. -4, right here. -4 minus 8 is -12. You guys agree with that? Is -13 greater than or equal to -12? No. -13 is over here. It's less than. So would -4 fit? No. Right here. You guys see my solution? Should -6 fit? I don't know. Let's see. It should. What's -6 minus 8? What's -6 minus 8? -14. Is -13 greater than or equal to -14? Isn't it greater than? That's the correct graph, not this one. It can't be. You just proved it. Okay, and here's the confusing part. There are two words that are going to throw us off today. Two little words. It's going to be the word... Actually, it's one of these two, but I'm going to show you both of them. The word and the word or. Okay, I need you to pick a side right here. Okay, everyone must pick a side. Everyone must pick one side. Do you understand me? You guys okay with that? Pick one side. Okay, and I'm just going to pick this here. You prefer this over that. So you can't say, I prefer both. No, just pick one or the other. Okay, cats or dogs? Okay, raise your hand if you're preferring cats in this class and you're going to prefer cats. No, one. I said one. Pick it. Nobody's going to prefer a cat. Okay, thank you, ladies. Thank you. Two. Sorry. Dogs. Should be everyone else. Stay with me. Stay with me. I'm trying to help. Okay, I'll wait.
My cat's evil. She won't let me pet me.
Okay. You either picked cats or dogs. Everyone should have picked. If you didn't pick, you're not a part of this anymore. So you pick cats over dogs or dogs over cats. That's fine. The important illustration is this. All right, ready? If you prefer cats or dogs, you will go to lunch when that bell rings. So who gets to go to lunch when that bell rings? Everybody. Whether you pick cats or dogs, right? You guys right? But they don't get to go to lunch.
I think Peter forgot to raise his hand.
I'm sorry. But I'm making an illustration. That's okay.
Yeah, Peter.
Time's not your friend right now. You have homework.
2 minutes.
Okay. Maybe for you more. So quiet. All right. You either prefer cats or dogs. And I said if you prefer cats or dogs, you can go to lunch when the bell rings. So everyone who picked gets to go, right? If I said this, listen to me carefully. If I said those who prefer cats and dogs, who raise their hands, cats and dogs get to go. So who gets to go in this room?
Everybody.
I'm just making an illustrative point. I'm not saying you can't go. You're all going to go. Listen to me, guys. Listen to me. We're struggling here, guys. I'm trying to give you help. I asked you the question, is -13 greater than or equal to -12? And the answer is true. Or sorry, it was false in this case. Because is negative 13 bigger than negative 12? No. Is it equal to negative 12? No. So we say false. It's neither. All right, your homework tonight, guys, is going to be 17 to 42.